Hey guys, so in this question, you have Q charge distributed uniformly over the curved surface area of a right circular cone. The semi-vertex angle of this cone is given as theta and the height of this cone is given as h. So this is your cone. Um, Charge is distributed over the surface of this cone. It has a height h, it has a semi-vertex angle theta. The cone is rotated about its axis with an angular velocity omega. So we need to calculate what's the magnetic moment associated with the cone, and it's given in this form. We need to find out what the value of n here is, over here is, right? So let me go about it the long way once, and then let me also point out what's the shortcut way of solving this question as well. Okay, so taking a cone, drawing this cone once again over here. So this is a cone right now. Okay, so first is realizing why we have magnetic moment over here. We have magnetic moment over here because wherever you have a rotating charge system, we can associate a current with that. We can say it's like a current carrying loop, and then any current carrying loop will have a magnetic moment, and the formula for the magnetic moment will be called IA, right? So here we just have to break it into parts and then find out the magnetic moment of each part and integrate the magnetic moment of all the parts over here. So let me select an element. Let me select an element on this cone at an angle at a distance x having a thickness dx. So basically I'm selecting this ring. I'm selecting this ring having a thickness dx right now, right? Okay. How much charge will I have on that cone? The charge on that cone I'll say is equal to the dq charge which I have on that cone is equal to sigma into the radius of this cone will be equal to x sine theta. So it'll be equal to sigma into 2 pi x sine theta into dx will be the charge I have on that cone. So what will be your current value on this cone? Your current value on this cone will be equal to dq divided by time period, which is sigma into 2 pi x sine theta into dx divided by 2 pi by omega. Divided by 2 pi by omega, so omega goes to numerator, so 2 pi gets cancelled. So this becomes equal to sigma omega x sine theta into dx. This will be a current value associated with this loop right now. And what is sigma value equal to? Sigma value itself is equal to q divided by the curved surface area, which is equal to pi rl. So it will be equal to q divided by pi rl. So since we need this in terms of height, let me write r and l in terms of height. So it will be q divided by pi. R will be equal to h tan theta and L will be equal to h by cos theta. So this becomes equal to q by pi h squared into cos theta by tan theta, which can be written as cos square theta by sin theta. So this is your sigma value, which we'll make use of later, right? For now, we have written the current. We have written the current in this. We have written the current in this loop in terms of sigma and x. In terms of sigma and x, and the value of current turns out to be sigma omega x into sin theta into dx. So what's your magnetic moment of this loop? Your magnetic moment of this loop then will become equal to I into pi r squared. So that will become equal to sigma omega x sin theta into dx multiplied with pi into r squared, and r value is equal to x sin theta, so that become x squared sin square theta. So this is your magnetic moment of this loop alone. So what will be your magnetic moment of the entire cone? Your magnetic moment of this entire cone is integral dm, which will become equal to sigma omega pi x cube sin cube theta into dx, as the x value varies from 0 to L, where L is your slant length of the cone. So this becomes equal to sigma is a constant, omega is a constant, pi is a constant, sin theta also is a constant over here. So it becomes sigma omega pi sin cube theta into L power 4 by 4. So this is your magnetic moment of the cone right now. Now I just have to write all of this in terms of h. So magnetic moment of the cone over here is equal to, so let me substitute all the values. L is equal to nothing but h by cos theta. L is equal to h by cos theta. Sigma is equal to nothing but q cos square theta by pi h square sin square theta. So let me substitute that over here. So pi omega sin cube theta is something which we already have. L power 4 by 4 will become h power 4 by 4 cos power 4 theta. And your sigma then will become equal to q cos square theta by pi h square sin square theta. So pi gets cancelled. H squared, h power 4 gets cancelled. I'll only left out with h square. Cos square theta by cos power 4 theta will give me just cos square theta. Sin theta divided by sin square theta, sin cube theta will give me sin square theta over here. So even this gets cancelled. So our final answer then just turns out to be q omega h squared tan square theta divided by 4. He's asking what the value of n is, and your value of n basically is equal to 4 in this case, right? So this is one way of solving this question, and this is actually a slightly lengthier way of solving this question. The easier way of solving this question will basically be making use of the gyromagnetic ratio, making use of gyromagnetic ratio. In all these kind of questions where you have a rotating charge, you can say m bar by L bar is equal to Q by 2m. So here your m bar, your magnetic moment of the cone, will basically become equal to Q by 2m into angular momentum of the cone. And angular momentum of the cone is nothing but I omega. Your I of a hollow cone is half mr squared, so it become half mr squared into omega. Right, I just now have to write this m and m gets cancelled, so your answer is basically Q omega r squared by 2. I just have to write this r in Q omega r squared by 4. I just have to write this r in terms of h right now. So this was r, this was h, this was your angle theta. So tan theta is equal to r by h. So h tan theta is equal to r. Substituting that over here, we'll get Q omega h square tan square theta by 4. So a much simpler way of answering this question, and this is probably what you should be using to answer these kind of questions, right? So hopefully this question is clear. See you guys in the next question.